Hello students, this is Dr. Diaz and I'm here to talk about the class today. So I completely understand that some of you is in transit and it could be online. Today we talk about this week that I call it Carbocation week because we have a rearrangement here. So the test 2 will be moved to Monday for me on October 21st and Tuesday for Dr. Bromfield, October 22nd. Just the video number 3 was moved early, October 8th, and the reading diagnosis remain, but we recommend that you doing it this week before the video. Please find out there on the Canvas the short videos that I have published over there is to help you to understand the questions the students send to me. So they'll help you to understand better some concepts. Maybe you have similar questions. So all the videos, short videos, and between 5 and 10 minutes videos are there, and they are answer for the questions that the students sent to me. Today we had a Kahoot as extra credit, and I sent you an email talking about this extra credit. But please complete the classwork complement, which is classwork 14. You're gonna find it close to the videos about part of the classwork 14 that you're gonna find with. So I wanna just answer a question. This is you're gonna find in my videos about do the elimination reactions always favor Zaitsev? If you ask me this question as it is, I would say no. But if you ask me if E1 reactions always favor Zaitsev, most of the time yes. So we can take a risk and say yes, it's always favor Zaitsev, which is the more stable structure here because we have more substituents. So when you draw eliminations, the errors and elimination, pay attention that the highlight over here, highlight will leave first, right? Elimination 1. And this will take the electrons with it. So the arrow must start over here at the bond and point to the bromine. So the base will extract the proton over here. Of course, it's only the proton, so the electrons will be left behind and form this double bond over here. Of course, the base can extract another proton and a beta carbon, so must be a beta carbon. It's a neighbor carbon over here. So alpha carbon is the carbon that carry the highlight over here. So and you're gonna have two products. Hoffman, that we have 1, 2 substituted, so is the least substituted is Hoffman, and Zaitsev that you can see here that we have 1, 2, 3 substitutions over here. You always look around the double bond. If you still have questions about this, so you have a double bonds and carbon. If you have only hydrogen here, this is not substitution. But if you have other elements over here, like I'm right over here, this is substitution. So here in this case, I have 1, 2 substitutions over here, and here, if I draw like this, I have 1, 2, could be like ethyl group on other elements over here, chlorine, whatever, for example, hydrogen. So it will be tri-substitute over here. So I have a di-substitute and tri-substitute. So an E1, you're gonna have Zaitsev as major. So please always write down both and show the arrows extracting the proton over there. But each reaction will be different. So the radioselectivity here will depend on the base. So if you have a sterically unhindered base, will produce more stable alkene, which is a Zaitsev. So in this case over here, we have a small base. And this base can extract this hydrogen over here. So we have one hydrogen over here. And this carbon, we have, of course, 3 hydrogens. So it's less substitute over here than here. So we can attack both, or extract one of this one over here or this one over here. And they're going to produce, again, 2 products. So, and again, the Hofmann here is the major product that we have, is the more stable. However, if you have a strong, let me raise this, because this always explain to a student that call me and ask for help. Imagine if I have the same product over here, same substrate, and now I have a book base. So I'm going to use the tert-butoxide, the one that I always use in example. And we can see here that it's a book base. So this is why it's one of the reasons that the nucleophilicity here decrease, but the base is strong. So this will always favor elimination over here. And however, if it's a book base, better place to extract hydrogen will be in the least substitute carbon over here. We have another carbon and a beta carbon. So over here we have another hydrogen. This is the beta, I would call beta 1, and this I will call beta 2. And this is my alpha. So because it's carrying the bromine over here, right? So what happened over here, the bromine will leave, and this book base over here will attack the hydrogen over here. So this hydrogen will leave behind the electrons. And what we're gonna have? We're gonna have this. So we're gonna have a double bond over here, right? But also we can have another product. So let's grab the hydrogen over here. So we'll extract this one. So, and we're gonna have this product here. So the least substitute, as you can see, I have here one substitution, another one substitution, and here just one, because in this side we have only hydrogen, right? So in this case, the favorite place to attack, and what this base will attack easily, is in the least substitute. So the major product will be Hofmann. So as I said in the last class, if you don't know, if you don't read well, if you don't know well about the eliminations, you're gonna think the book is bipolar, because one time it says that it's always Zaitsev, and then you read and it says that, oh, in this case it's Hofmann. So this is why you cannot ask the general questions like elimination reactions always favor Zaitsev. Elimination 1 will always favor Zaitsev. Elimination 2 will not. We can have major as Hofmann. So most of the time we have Zaitsev, but in this case we need a small base. Another thing to remember is E1 mechanism will favor Zaitsev. Doesn't matter what do you do, because you cannot change this ratio selectivity, even if sterically hindered alcohol is used as a weak base, because we have a carbocation over here. And also the E1 reactions can undergo rearrangement. Another point that you need to remember. So the only elimination that you can control the product through the different base is E2. So if I want to produce this product as my major, I know that I need to use a book base. If I want this product as major, I know that I need to use a small base. I'm sorry. So, and the E1 mechanism, no, because we cannot control this. We always favor Zaitsev, okay? And about the rearrangements, like I said at the beginning, this wick is the carbocation wick, because we can do rearrangements, and actually we must have. So in this case here, chlorine left, this is the leaving group, and we have the positive charge over here. And this is the carbon, secondary carbon. But remember that I said since the beginning the carbocation, positive charge, will be better when it's located in a tertiary carbon. And look at this, this is a tertiary carbon, right? And remember that we talk about hydride shift. So this is the case that we can have a hydride shift. So imagine we have a hydrogen over here, right? We have it actually two. So this hydrogen will move its electrons, or the electrons, that is the movement of electrons. So there is a movement of electrons, not this one, sorry. Not this. This will not move because this is in the charge over here. So we need to move this hydrogen over here. So the movement of electrons that we carry the proton together. So all the electron and the protons goes in this place over here. So then I'm gonna have the replacement of this positive charge, actually the shift of this positive charge, because now this hydrogen over here is over here. Okay, so now my charge is in a tertiary carbon, is more stable. So when my base attack the proton over here, or could attack as well the proton over here, right? So we could have two products over here, but the major, we know the major in this case will be this. So the hydrogen will leave behind this here, and we're gonna have a Zaitsev product. And here we have 1, 2, 3, 4 substitutions. That's tetra substituted. So that's it. That's all.